Now I would like to clarify some misunderstanding in chemistry. I would say it's the most common misunderstanding is what's the difference between intermolecular forces and intramolecular forces. Let's talk about intra first. Intra can be ionic, metallic, and covalent. In one of my videos, I already talked about covalent, so go watch it. It's explained in a very simple and easy to understand language. Intramolecular forces is when you have a compound, let's say H2O, and you split it into elements, right? Which are the elements there? Oxygen, hydrogen, and hydrogen. Well, the intramolecular forces is these guys here. So it's inside the molecule. Now, what about intermolecular forces? Intermolecular forces could be ion-ion, dipole-dipole, ion-dipole, hydrogen bond, and London dispersion. I'm not going to go over all of those, but I want to give an example. So I'm going to give example of ion-ion, and the easiest example is NaCl, right? But if intramolecular forces is the bond between Na and Cl, ion-ion is actually bond between two molecules. Now, we know that chlorine is charged negatively and sodium charged positively. Chlorine negative, sodium positive. We know that positive and negative, right? They can be combined together. So the bond will be this. Now imagine, why is it happening? Because if we didn't have that, we would have only one molecule not connected to anything else. And obviously, we are not going to have big quantities of those, for example, right? Now, you probably heard about hydrogen bond. So I'm going to give another example of the hydrogen bond here. Hydrogen bond is the bond between, obviously, hydrogen, right? And either of those three elements that I'm going to provide right now. So it's bond between hydrogen, oxygen, nitrogen, and fluorine. Only those three. If you see bromine, that's not, the bond between them is not going to be a hydrogen bond. So only those three. Now, how does it work? I'm going to give example with water. Now, water has oxygen, hydrogen, and hydrogen. And another molecule of water will also have oxygen, hydrogen, and hydrogen. We know the common formula, right? So if between them, right, this is intramolecular forces, so inside the molecule, then the outside molecule will be hydrogen bond. Why? Because we have H and O. H and O, as I said, hydrogen bond can be created between those two. So again, this is one molecule, this is second molecule. Connection between them is the hydrogen bond or intermolecular forces in general. You can memorize it as these is relationships between neighbors, whereas this is relationships inside the family. So again, just to repeat, what I'm highlighting right now is the relationships inside the family, right? Inside, between brother and sister, between mother and father. But this one is the relationships of the neighbors. So two families, how do they get along together, right? And those are different types of their relationships, these guys here. Now, if we want to discuss dipole-dipole, that would be two nonmetals, similar type, HCl and HCl. Between H and Cl of different molecules, this is the first molecule, this is the second, will be dipole-dipole over here. Why is it happening? Because chlorine is partially negatively charged. Hydrogen is partially positively charged. Partially positive, partially negative. About partial charges, it's a little bit different topic, so we can cover it during our sessions, and I can describe very in details that concept. So that's it. Since it's negative, this is positive. Of course, we know that positive and negative get combined. They get attracted to each other. And here we go. That's your dipole-dipole. I think we covered the main ideas, so I hope now you see the biggest difference between inter and intramolecular forces. The only thing I want to add is that intermolecular forces, which are these guys, there could be several in one molecule. For example, water will have not only hydrogen bond over here, but also dipole-dipole, right? Because dipole-dipole is nonmetal and nonmetal. Here is nonmetal, here is nonmetal. Also, it's going to have London dispersion forces. What are the London dispersion? London dispersion are the weakest ones, and every single molecule has it. Every single one. So it's easy to remember. If you see a molecule, you can already get 30% on the question. You can say it's London dispersion forces if you're asked about intermolecular forces. If you're saying London dispersion, 30% in your pocket, and then the rest, you just figure this out. So for the water, it's going to be hydrogen bond, dipole-dipole, and London dispersion. Whereas for intramolecular forces, we can only have one out of these three. Well, that's pretty much it.